Hey, this is Mr. Miller here. Today we are looking at introducing exponential function notation. Mainly function notation. So make sure you write your name at the top of these notes right up here. And let's get started. These notes should be pretty brief, more focused on your practice with these functions today. So a common equation that you've all seen before might look something like y equals 2x minus 5. That looks like something that you've seen in class before. You are able to solve for the variable y as long as you're given the value of x. So you can solve for this variable y as long as you have some number you can substitute here in for x. So say I said x equals 4. You can substitute 4 in for this x and find your value for y. So functions, they're more common in real life. They use outputs and inputs. So in a function in real life, there's always something coming out of the function. There's always something you're putting into the function. So this equation, y equals 3x plus 4, in function notation, all you're doing is instead of writing y equals 3x plus 4, you're writing f of x equals 3x plus 4. So the only thing that's changing is in equations where we have the y, functions, we're writing f of x. So right here, what does y equal? Well, it's the same thing as f of x. So y and f of x, these numbers, these variables, terms right here are interchangeable. Anytime you see a y, you could always substitute an f of x. Anytime you see an f of x, you could always substitute a y. The x is always going to be your input. F of x is your output. It's whatever your answer is to your equation. So that's just briefly introducing function notation. Let's look at two brief examples. Starting with the equations, let's solve this equation y equals 3x plus 4. And let's say that we know x equals 2. So in order to do that, we will rewrite our equation. Y equals 3 instead of x. Since we know it's 2, we'll substitute 2 in for that x plus 4. We can simplify that a little bit further. Y equals, well, 3 times 2 is 6. And then you add that plus 4 on the end. Last step, 6 plus 4 gives your answer of 10. So we know that y must equal 10. You should know how to do that. Sounds good. What's new today is this function notation. So we have this original function f of x equals 3x plus 4. In function notation, if I want to solve this function f when x equals 2, notice how instead of x we just replaced it with 2. That tells us our input, our x value, is 2. So when we write this right hand side of the equation, instead of x, we're going to substitute in that value of 2 plus 4. So f of 2, a little bit too far, f of 2 equals, well, 3 times 2 is 6, plus 4. Sounds good. Our last step here, f of 2, well, 6 plus 4 gives us 10, so f of 2 equals 10. Now, I want to highlight this bottom part right here. When we solve equations, we usually get an answer one variable equals a number. That's a lot of times how it ends up, y equals 10. On this right hand side here, you can see f of 2 equals 10. The major benefit of function notation is that when you solve it, you can see what your input is. So f of 2 equals 10, you know that when x equals 2, your output is going to be 10. So you know right away a solution to that equation right there is 2 comma 10. You can come up with a solution right there. In this equation form right here, well, you know that y equals 10, but in order to find out what x is, you have to look all the way back to the beginning. It's fine, but it's a little more difficult. Just one of the reasons why we use function notation. If you feel confident, flip this sheet over and try the practice problems. If you're still struggling a little bit, look at the next video and I will walk you through how to solve each of those problems on the back side. Peace out.